Before we look at how we are going to reclaim a soil which has a pH too high or alkaline, or a pH which is too low or acidic, I would like to first look at the importance of soil pH and how it affects the solubility of nutrients in the soil. Earlier we talked about the hydrogen ion and how we actually measure that in determining the pH of the soil, but we did not talk about how solubility of nutrients is directly influenced by pHs of the soil. So with that introduction, let's look at a graphic which shows us how the solubility of nutrients is affected in the soil as the pH of that soil goes up and down the scale. This first graphic is entitled Soil pH Affects Availability of Plant Nutrients. The way in which we need to read or interpret this graphic is we look first at the bottom scale. Here is our pH scale, in this particular case starting at a low of 4.0 and progressing up through a high of 10.0. Now I said earlier that the pH scale runs from technically 0 through 14. But we need to understand that soil pHs below 4, which would be extremely acidic, or above 10, which would be quite high or quite alkaline, are very, very rare, and under those circumstances we would have multiple problems with plants growing in that particular soil. So the range of pHs from 4 to 10 is really adequate for us considering the solubility and therefore the availability of any particular nutrient. And as we can see up here at the top of the chart, we're in words describing the pH of that particular soil. If we were down here between 4 and about 5.5, we consider that to be a strongly acid soil. Medium acid would be 5.5 to 6, slightly acid would be 6 to 6.5, very slightly from 6.5 to 7. And for all practical purposes, we really consider soils with a pH from 6.5 to 7.5, or within that 1 pH range or unit, to be, for all practical purposes, neutral. As we progress above 7.5, we get into slightly alkaline and medium alkaline. We begin to see a restriction here in terms of the growth of certain species of plants, and especially in terms of the solubility and therefore the availability of some nutrients. And then, of course, when we progress into the strongly alkaline range, pHs above 8.5, we have similar problems there to what we do with the very strongly acid range down here, and that is that few plants make good or adequate growth in those pH ranges. On this particular chart we have a number of bars. The width of the bar is showing the relative solubility and therefore availability of any particular nutrient. So if we look at the first nutrient on this graphic, it's nitrogen. And we see that nitrogen, because the width of the bar stays relatively wide over a broad pH range, is really not a nutrient which is highly affected by soil pH in terms of its solubility and therefore availability. Not until we start getting down to pHs below 6 and even down into almost the 5.5 range do we see a restriction on the availability of nitrogen. And the same would be true going upscale. Even at a pH of 8.0, we still have a relatively wide band for availability of nitrogen. If we move to the second nutrient, phosphorus, we can see that that is definitely not true. Phosphorus has a very restrictive band as we progress below this slightly acidic range down into the 6 range. See how much narrower the band is here than it was for nitrogen, the nutrient above that. And as we progress upscale away from neutral, we also see a restriction in the availability of phosphorus. That changes and it becomes quite soluble and quite available again up here at a pH somewhere between 8.5 and 9, but that is really not practical in that soils with this pH range, even though phosphorus is highly soluble and therefore available, have many other nutrient deficiency problems related to solubility and improper pH. Potassium is not a nutrient that's highly affected by soil pH. Sulfur, we could say the same thing for that one, also not very pH critical. Calcium and magnesium, the two primary basic soil cations, We would expect those to be most available around neutral and even slightly above, and indeed that's true. As we progress downscale in pH, we are seeing a reduced availability of these nutrients, and that's really kind of a twofold effect. If we have pHs that are down here in the slightly acidic range, at 6 and even down to 5.5, the medium acidity range, we naturally have lesser amounts of calcium and magnesium in solution, because these are the basic cations that help balance or offset the hydrogen, and if they were there in appreciable amounts, the pH would not be down in this acidic range to begin with. Iron, manganese, boron, copper, and zinc, these are all micronutrients required by plants in small quantities. In general, we can say that they are all more soluble and therefore more available as we progress into the acidic soil pH ranges. Boron has a similar effect to what phosphorus did above, in that it widens out again up here at a very high pH range. Not really that significant, however. And the one exception on the micros, at least the ones listed on this chart, is molybdenum. Molybdenum is a nutrient which is quite soluble and therefore available around the neutral range, 6.5 to 7.5, but actually shows a sustainable solubility and availability as the pH goes up, whereas if we progress downscale, it's just the opposite of these other micronutrients listed above, in that its solubility and therefore availability becomes restricted as we get into the acidic soil pH range. Well, what would I like you to take away from this particular graphic? Not at this point in time do you need to know how each one of these nutrients is affected by soil pH in terms of solubility and therefore availability, but more the generalities, in that pH determines the solubility of the nutrient, and solubility for practical purposes does determine availability in the soil to plants that grow in that soil. Other than that, also some generalities in that the macronutrients are less severely affected by pHs than are some of the micronutrients. And of course, a deficiency due to a lack of solubility of any one of these, since they are all required plant nutrients, can have just as a dramatic effect, even if that nutrient is a micro used in small quantities versus a macro that's used in a larger quantity. So those are some of the general thoughts or ideas that I would like you to take away from our discussion on this particular graphic at this point in time.